Assalamualaikum and hi everyone. My name is Faizal. I am from Group 10. We present our topic which is Green's Theorem. We start with the general question first. So let D be a simply connected plane region whose boundary is a simple, closed piecewise, smooth say oriented closed counterclockwise. If function P and function Q have continuous first partial derivatives on some open set containing C, then D is the general uh, equation for Green theorem, and this symbol represented the closed curve integral. This is a example, sketch example that for you to better understanding. This is represent the region of the shape, symbol close curve D and the region at D. Okay, first of all, this green theorem works only for the case where C is simply closed curve. Okay, if C is an open curve, please don't even think about using this green Green's theorem. So Green theorem convert the line integral to a double integral of the microscopic circulation. The double integral is taken over the region D inside the part. Only closed part have a region D inside them. The idea of circulation makes sense only for closed part. And second, Green theorem can be used only for vector field only in 2D. It cannot be used for vector field in 3D. So don't bother with Green theorem if you are given an integral right this equation. This is a integral equation that in 3 dimension. Note that this Green theorem only used for 2D only, even if C is a closed part. Okay, that's all for me, and my friend will continue for the other session.
Assalamualaikum. My name is Muhammad Fadhil bin Muhammad Noor. I am from Group 10. I will continue to example 1. Uh, by closed curve integral equation, y minus cos x dx plus sin x dy, when C is the perimeter of the triangle formed by lines y equal to 0, x equal to pi over 2, y equal to 2 pi over x. Gather the information from the question, we get fx equal to y minus cos x and gxy equal to sin x. And then we sketch the graph for xy at the xy plane by the equation given in the question, and then we get the graph like this. Then by using the equation of Green theorem, we take the information that we have into this formula, and then we integrate this, and then we get cos x minus 1 dy dx. This limit we get from the question that has been given. That's all from me. Thank you.
Assalamualaikum. I am Muhammad Ali Akhtar and from Group 10. I will continue the explanation of question 1, example 1 from Fadhil. We get the equation of integrate from 0 to from half pi and to 0 and 2 over pi x to 0 integrate for dy dx of cos x minus 1. Then we can integrate the dy dx to cos x minus 1 y. Then we could multiply the 2 over pi x inside the equation. Then we get this equation, cos x minus 1 and 2 over pi x. After we multiply the boundary of dy, we need to use tabular method to solve equation inside the bracket, because we use tabular method because there are two unknown inside the equation. Then we get this equation that is easier to integrate dx. When we integrate dx, we have it, it is easier to split the equation into two parts, the cos x and the x. After the integration of the dx, we can multiply the boundaries into the equation for both the equation. Then we get the final long equation, and we can simplify it to 2 over pi multiplied by half pi minus 1 and minus 2 over pi multiplied by 1.23 and 234.
Assalamualaikum warahmatullahi wabarakatuh. I am Aminin bin Nasaruddin from Group 10. Now I will continue for the second example for the green theorem. The given question is closed curve integral 2x minus y dx plus xy dy, where C is the boundary of the region bounded by a circle x squared plus y equal to 9. By the using green theorem, gather the information from the question. So by fx and y is equal to 2x and xy is equal to gxy. From the question, we know that the region for this question is circle. So by using the equations given, as we know, x squared plus y squared is equal to r squared. So r squared is a radius. So by using the information here, you can plot the graph like this. By sketch the r region at the xy plane exists using this equation. So we get like this. By using the general equation of the green theorem, that is delta over delta x, this is gxy, and this one is minus delta over delta y, this one is fxy. So we differentiate it, we can get y plus 1 r d theta. Why we use this? Because it's a as we know, dA can be anything, dy dx, or dx dy, or r dr d theta. So by using this equation, we can get the limit by referring to the graph. So for the first one is dr 0 to 3, 0 to 2 pi. Thank you.
Thank you, Amin. My name is Shahrul Azlan. So I will continue for the calculation general equation, which is limit for delta is from 0 to 2 pi, and limit for radius is 0 to 3, and y plus 1 r dr d theta. So firstly, we need to know that y is equal to r sine theta, which is we already learned in chapter 2. So we put r sine theta inside y, right here. Then we multiply with r here, so we will get this equation, which is r plus r square sine theta. Then we integrate with the limit of 0 to 3, and we get r square per 2 plus r cube sine theta over 3 with limit of 0 and 3 d theta. Then we need to divide it into two parts, which is for r square here, where's r square here, square, and for r cube sine theta. Then we put the value of 3 and 0 inside r square and r cube, then we will get this is general equation. This one is I already simplify because we know that to make it simple we need to get the same base. So we will get limit 2 pi to 0 r square multiply with 2 sine theta r plus 3 over 6 with limit of 3 and 0 d theta. Next, we put, I'm sorry, we didn't put 3 and 0 yet. So we put limit 3, the equation for this side and minus when we put limit 0 on this side, then we will get this equation which is limit 0 to 2 pi 18 sine theta plus 9 over 2 d theta. This also I already simplify the equation so we can easier to calculate. So the second integration, we will integrate for theta. So from this equation, we integrate for theta, we will get 9 theta minus 18 cos theta over 2 with limit of 2 pi and 0. Then just like we learn how to integrate, we put the minus with 0 pi on the right side. Then we get 9 pi. I guess that's all from